So part 5, 2014 question 10. Not a bad question. Let's have a look at the study the reaction scheme below and answer the questions to follow. Compounds X, Y and Z each have 2 carbon atoms. So 2 carbon atoms. So that means alcohol X, that has to be ethanol. Aldehyde Y definitely has to be ethanal. And then your carboxylic acid has got to be ethanoic acid. So 2 carbons gives you those 3 compounds. Give a major use for compound Z. So compound Z is ethanoic acid. A major use, of course, the obvious one is vinegar. It's also used as a solvent. You could say that as well. And then it's also used to produce acetate. In biology, it's cellulose acetate. But vinegar is the obvious option, so go with that. Part 2 then. Draw the structure of aldehyde Y, showing the bond between the atoms. So you got to draw aldehyde. So C double bond O and then a H. And then if it asks you to draw the structure, do fill in the H's. You don't have to put in the H per se, but you have to put in the bonds around it. Just make sure that's done properly. And that is it. Part 3, draw the structural formula of the ester that's formed from compounds X and Z. So X and Z is ethanol and ethanoic acid. So when you react ethanol plus ethanoic acid, you're going to get an ester and water. So an alcohol and a carboxylic acid gives you an ester and water. So let's have a quick look at these molecules. So if we're drawing out ethanol, ethanol is going to be C2H5OH. Here's your OH group plus your ethanoic acid. C double bond O and OH. And that's going to give you your ester and water. So here we've got a simple substitution reaction. So what happens is this H and this OH, they form the water. That's going to give you your plus H2O. And then the ester is what's left over. And what happens is what's left of the ethanol, that joins on in place of the hydrogen. So you end up with a compound that's shaped like this. See, you keep your basic structure of your carboxylic acid, but then it goes O, and then the ethanol part is actually a C2H5. So this is the compound. So when you're asked in this question, just move down and get a bit of space. You're asked in this question, draw the structural formula of the ester formed from compounds X and Z. This here is your structural formula. Now again, you don't have to write out that full equation. That's just to help you explain. That's all that's required. If you're asked for the name of this, again, you're not, but let's put in the name anyway. We're looking at the ester, which is C double bond O-O-R. So that's the ester part, and it has 2 carbons in it. So this is an eth, it's an ethanoate, and then the C2H5 gives you the ethyl. This compound is ethyl ethanoate if you're asked for it. And I think that is it. Oh, and then the last one then says identify any carbon atom in this ester that is planar in geometry. Okay, so let's have a look at this compound. So planar is generally on the carbonyl. So if we look here, this carbon here, this is the planar. Whereas the carbon that's here is tetrahedral. Again, it doesn't ask that, but just if you need to know what it is, that one's planar. And then finally, how could aldehyde Y be reduced to aldehyde or alcohol X? Again, this question keeps coming up. How do you reduce an aldehyde to an alcohol? And the answer, of course, is with hydrogen and a nickel catalyst. So again, H2 with a nickel catalyst. Okay, so let's move on to 2019. Now, for some reason, the reason why 2019 is coming after 2014 is when I copied these out of study clicks. For some reason, study clicks says 2019 after 2014. So it's in here. Let's have a look at it. So part A, the mechanism for the substitution reaction between methane and chlorine, so that's come up again in ultraviolet light, involves free radicals. And you have to explain the underlying term. So what is a free radical? Of course, we could probably draw a free radical fairly easy, but it is just an atom that has an unpaired electron. So an atom that has an unpaired electron. So again, your chlorine free radical would be written like this. And again, that's an electron in chlorine that is unpaired. Part 2, how are chlorine free radicals formed in the initiation stage of this reaction? So once you know your mechanism, it's a fairly easy one to answer. You have a chlorine molecule, which is shaped like this. And when that is put under UV light, you end up breaking up into chlorine free radical and another chlorine free radical. So if you write something like this, that's perfectly allowable. And then put some arrows in. And you can put this in words if you want. So if you wanted to put it in words, you could put in something like, Cl2 molecule. Cl2 molecule is broken under UV light to give 2 Cl dot free radicals. You can do it like that as well. It really doesn't matter which way you do it. Part 3. What name is given to the stage of the mechanism where a chain reaction is occurring? So you have to analyze where the chain reaction is starting to occur. Once the reactions start happening, then that's going to give you, the chain reaction. It has a knock-on effect. So this would be a stage called propagation. And this is where the individual free radicals start acting on each other and reacting with each other. So write a balanced equation using dots and to label the free radicals for the 2 reactions that repeat in a chain reaction to give chloromethane and hydrogen chloride. So you're given a clue here. You're told that you want to get chloromethane and you're told you want to get hydrogen chloride. So all you've got to do is draw it out. Well, the whole point of this is that you're dealing with a chlorine free radical. And it says the reactions that repeat to give chloromethane. Well, if you want chloromethane, you're going to have to react chlorine with methane. So that's your 2 reactions. So what happens in this particular instance? Well, again, you want to form chloromethane. So if you want to find chloromethane, you're going to have to try and break up this methane and the chlorine's going to have to join on. So what happens is one of the hydrogens reacts with the chlorine. So you end up with HCl plus CH3, because one of the hydrogens is gone, and that's your free radical. Now we're not quite there yet. Hydrogen chloride is now formed. So this is your hydrogen chloride. So what about the chloromethane? Well, that CH3 free radical now reacts again with chlorine gas, or the chlorine molecule, which is in solution as well, and that ends up forming this, and it frees up a Cl free radical, and then this here is your chloromethane. Okay, moving on to part 4. Identify a hydrocarbon. Identify a hydrocarbon that is formed in the process and explain why 1 trace quantity is formed in this particular instance. So a byproduct of these, of course, is ethane. And where do we get ethane from? Well, if you have a methyl free radical and you have another methyl free radical and the 2 of them react to each other during a chain reaction, you end up producing this. They just join together, and this, of course, is ethane, and this is a hydrocarbon. So this is the sample that it's talking about. And explain why only a trace quantity is found in this product. And one of the main reasons for that is in a reaction, let's clean this up. In a reaction, your methyl free radical, your CH3, the methyl free radicals generally will react with chlorine molecules. That's generally what happens. So it actually rarely happens that you would have a methyl-free radical and another methyl-free radical actually hitting off each other. So that gives rise to the trace amounts. And again, you can word that in different ways. That's perfectly fine once you mention that most of the reactions involves the free radicals and the chlorine molecules. Let's move on to 2019. The table shows the boiling points of 4 primary alcohols and 2 secondary alcohols. And then part 1 asks you what is a secondary alcohol. So of course a secondary alcohol is where the carbon bonded to the OH, the OH group, okay, is bonded to 2 other carbon atoms. And that's your secondary alcohol. On the same sheet of graph paper and using the same pair of axes, plot the boiling points of these alcohols against the number of carbons present. Okay, so I will try and do some sort of a graph on this, and I'll be back in a second. Okay, so we have this graph drawn out. So here it is here, the chart title. So a couple of things about the chart. There's all the points plotted. You need to label your sides. So obviously the numbers on the left hand side, this is temperature in degrees Celsius, and don't leave out these. This here is the chemical or the alcohol along the side. And when you're working on this, you're going to get 3 marks if you have at least 1 numeric scale. So in other words, you know, label the axis. That's for 3 marks. You're going to get 6 times 1 mark for your 6 points. Marking schemes often say you don't have to join these points together. I would just join them together just in case. Let's move on to the questions then on the chart. So the first question says, or the third part says, state and explain the trend. So state and explain. A lot of students miss this. You have to state and then give a second answer for explain. So again, if you want to state here what's actually happening in this graph. Well, it's a general trend, so it doesn't have to be super accurate, but in general this is an increasing. In other words, as you go across, the more carbons you add into your alcohol, the more the boiling point increases. Yes, there's a dip there, propan-2-ol and butan-2-ol at the end, but in general it's increasing. And again, what's the explanation? You have to be able to explain why it's increasing. And the explanation means that there is, you know, there's more attractions between the molecules. So there is more intermolecular forces as you increase. Therefore, you need more energy to break the bonds. So that answers that question with the graph. Part 4 then says predict the approximate boiling point of the next alcohol in the same series as propan-2-ol and butan-2-ol. So the next boiling point, so propan-2-ol and butan-2-ol. So let's have a look here. There is propan-2-ol, there is butan-2-ol, and it does, if you're looking at this, where is this? It's almost on the line. This one here is on the line. So if you were to predict the next one will probably be on the other line as well, somewhere around there. Now again, this question says predict. So when it says, oops, sorry, it's the question below. When it says predict the approximate boiling point, it will allow you a range. So if I'm looking at this here, I will probably go with something like, I don't know, maybe 119 degrees or 120 degrees Celsius. And I think I remember from looking at the marking scheme earlier on in the year, it allows you somewhere between, I think it's around 105 degrees, and it goes quite a bit up over it. I think it's 125 or 130 degrees Celsius. So there's plenty of range for you to get your answer in there. But again, it's just an estimation.